All right, let's dive in. We're going to pull back the curtain on the technology that powers, well, pretty much everything we do. Information and communication technology, ICT. It's kind of like the invisible architecture of our modern world, and over the next few minutes, we're going to make it visible.
So let's kick things off with a really simple question. Have you ever stopped to think about what really happens when you click save? You probably do it dozens of times a day without even thinking about it. But what's actually going on inside the machine at that very moment? Where does your information go? And how does it know to come back when you need it? That one little click, it's the perfect way to start exploring the world of ICT. Well, at its heart, that single click is part of this huge, massive system we call information communication technology. And look, this isn't just about computers. It's the whole shebang, the entire ecosystem of devices and services that we've built to handle the frankly unbelievable amount of data we create every single day. It's how we collect it, how we share it, process it, and store it all.
And this whole system, it's doing way more than just managing our files. It's fundamentally changing how we as a society move forward. Seriously, this isn't just another tool in the toolbox. In a lot of ways, ICT has become the new direction of progress itself.
Just think about it for a second. We're generating new information in science and tech in our everyday lives at a rate that is just staggering. And without a system to manage all of that, to find the signal in the noise, all that knowledge would be totally useless. ICT, that's the framework that lets us make sense of this incredible explosion of information.
Okay, so how does this massive system actually work? To really get it, we've got to peek under the hood, look inside the box, and understand the two fundamental parts that make every single computer tick. Its hardware and its software. And man, what a box it's been. The physical machine, the hardware, has evolved so dramatically. The first generation of computers, like the famous ENIAC, they were absolute behemoths. I'm talking, they used vacuum tubes, filled up entire rooms, got incredibly hot, and just guzzled electricity. Now just compare that to the powerful, portable, fifth-gen devices we carry around in our pockets today. The change is, well, it's just incredible. This really gets to the core of it all. Here's a great way to think about it. Hardware is the body. It's all the physical stuff you can actually see and touch. The processor, the screen, the keyboard. But a body without a mind is, well, it's just an empty shell, right? That's where software comes in. Software is the soul. It's the set of instructions and commands that tells the hardware what to do. It's what truly brings the whole thing to life.
All right, so we've got the body and we've got the soul. Now let's see how they actually work together. We're going to go inside the machine and try to understand how it thinks by following the journey of just a single, simple command.
It's kind of wild, but every single thing a computer does can be boiled down to this fundamental three-step cycle. First up, there's input. That's you typing on a keyboard or clicking your mouse. Next comes processing. The computer's brain, the processor, takes that command and carries it out. And finally, number 3 is output. The result shows up on your screen or, comes out of your printer. Input, process, output. That's the loop. And it's running millions, even billions of times a second.
Okay, but hold on. How do you, the human, actually talk to the processor? That's where the operating system, or the OS, comes in. The best way to think of it is like a translator. You give commands in a way you understand, right? By clicking on icons or typing words. The OS takes that and translates it into a language the hardware can actually understand and execute. And here's the most important part. Without an OS, there's just no bridge between you and the machine. It can't function. So where does all this magic happen? Well, it happens in the computer's memory. And there are two main types you need to know about. First, there's RAM. Think of RAM as your desk, or maybe a workbench. It's a temporary space where the computer puts all the files you're actively working on right now. It's super fast and flexible, but, and this is a big but, when you turn the power off, that desk gets completely cleared. Then you have ROM. ROM is more like a printed instruction manual that's built right into the computer. It holds the permanent, unchangeable instructions that the computer needs just to start up. And unlike RAM, it doesn't need power to remember its stuff.
Okay, so now that we've got a handle on the guts of the machine, let's talk about what we actually do with it. And that's where application software comes into play. You can think of it as your digital toolkit. These are the programs that turn a general-purpose machine into a super specific tool for a specific job, right? You need to write a report, you open up a word processor. You need to crunch some numbers and make a graph, you fire up a spreadsheet program. From making a presentation to just browsing the web to find information, these applications, these are the essential tools in that digital toolkit we were just talking about. So when you zoom out, you see that this incredibly complex ecosystem of hardware and software hasn't just changed the way we work. It's literally created entirely new industries and brand new career paths. And the opportunities are just so diverse. I mean, you could work in software, creating the very apps and operating systems we all use every day. Or you could go into hardware, designing and building the physical machines themselves. And then there's this super important human side of things, training people how to use all this tech and, of course, marketing it to the world. And the people in these new careers, they've led to some absolutely incredible landmark achievements all over the world. A perfect example of this is India's very first supercomputer, which was named Param. Now, this wasn't just another machine. It was a really powerful statement about technological capability and a massive, massive leap forward for the whole nation. This groundbreaking work all happened at CDAC. That's the Center for Development of Advanced Computing in Pune. And under the leadership of Dr. Vijay Bhatkar, this team didn't just build a supercomputer. No, they helped forge a completely new direction for the entire country's technological progress. So, from a single mouse click all the way to a nation-building supercomputer, we've seen just how much ICT has evolved. But, this is also a story about how we've evolved right along with our tools, which leaves us with one last, really crucial question to think about. As this technology gets even more powerful and becomes even more a part of our daily lives, how is it going to end up shaping you?